Thanks for clicking on the video. Like, subscribe, and share if you find this useful or interesting. Today we're going to sculpt the curves on this cap to be three-dimensional. Right now, these curves are drawn in the same plane as the layout, which controls the overall shape. The layout is these light yellow lines. We're going to start with this curve. We're going to go from here, we're going to go up and out of the plane of the layout and then back down to this point. To see how this all works, let's tweak these blending points a little bit. Last time we just organized them and set them. Let's put them back to bigger values so we see bigger blends. 0.25 on the first one. 0.75 on this one. .25 on this one. .75 on this one. Okay, I don't really care about the bottom right now because we're going to be working up here. Okay, so let's get right to it. To make three-dimensional curves, we can't just draw a single sketch in a plane, right? We still need to have a control polygon that has three lines, but we're going to make it differently. Instead of a single sketch, we're going to make it out of two independent sketches. How does that work? Let's make a sketch. XY plane. I'm going to clip so this is not in our way. And although you don't have to put this at the origin, putting it at the origin is the most useful way to do it. So you should definitely start by making it at the origin and only break away in special cases. By putting it at the origin, we'll be able to move the entire sketch and snap its origin to something. And this will make connecting lines much, much, much easier than if the circle is floating in space. The circle indicates the beginning or the end of a curve, and the line indicates the tangent direction. Okay. I'm going to give it an overall dimension. So the circle is just a visual indicator of which end is which. I'm going to make this size 20. And to control this point here, it's very tempting to put an angle dimension right here and then a length. But angle dimensions love to flip around the axis in FreeCAD all the time. And this is not just FreeCAD. This is pretty typical across many CAD systems. It's hard to control angles so that they don't flip. So I'm going to use instead is the constraint lock, because the constraint lock allows me to put in negative dimensions. And so I can flip this thing to wherever I want with just two dimensions. And I find that to be very useful in practice. Okay, so 20. And the default sketch, I like to put it more or less along the X direction. So when I look at this, when I move this thing around, I'll know where its X-axis is. It's more or less along this line, and then its Y-axis is on the other side. Okay. So this is a good default object right here. I'm going to call it node sketch 000. I'm going to put it right in my utilities. Right off the bat, I'm going to copy it, make two copies, hide it. These two copies, I'm going to move them off to the side for now just so that they're not on top of the model. I'm going to move them at X minus 500. And I just did that on both of them, but now I'm going to select just the second one. I'm going to give it a Z of 300, a Y of 100. So now these are not in the same plane, and the origins don't have a simple relationship to each other, right? They're offset in all three directions for this one. I'm even going to do one more thing on this one, is that I'm going to give it a rotation so that these two planes are not even parallel to each other. They don't have the same origin, and they're not going to share any of the same axes, right? So rotating around Z would be pretty meaningless because it would still be in the XY plane. I'm going to set the rotation axis to be around the X and give this an angle of 45. Okay, so let me see. These two sketches are completely rotated and independent, completely three-dimensional. When I click one and I click the next, I get a control polygon. Now, this control polygon is three-dimensional, but it does the exact same thing as the one we had created right here. It just gets the data from the sketches and it prepares an object that we can make curves from. I'll hide this guy. So here, I can put a curve on here. And this curve is completely three-dimensional. This curve does not lie in any plane. Right? Like it's not here, it's not there. You can't twist this thing to ever see a line. Okay. But to make the library object that has all the points and all the cut segment curves, I don't actually need this curve here. I'm just going to copy the curve in 3 segments with the points and the segments and everything that was made with a 3-line sketch. I'm going to paste it. I'm going to delete the control sketch and the control polygon and keep the curve. A control poly 3L expects one sketch of exactly 3 lines. And it can only handle one sketch. So I can't just feed it these 2 node sketches. They need to have their own control polygon, which is the control polygon 2L. So right now I don't need this control sketch 3L. And this breaks, that's fine, I don't need it. What happens when I hit the curve? The cubic curve wants a poly, but it doesn't care what kind. Before it had a control poly 3L, now we have a control poly 2N. It has, because I deleted it, there's no more reference here, and I'm going to add the reference to this new one I've made. I could click it in the 3D window, I could click it right here, or I could scroll down this insane object list and click it from the bottom. I'm going to click it in the window. It highlighted in the tree, it highlighted in the list, I hit OK. And when I hit F5 to recompute and show the objects, everything we've built for these planar curves, well, now we have it for a 3D curve. So I'm going to take the 2 node sketches and put them at the top. They are the objects that were created first. And then this control poly goes right in between the sketches and the curve. This polygon is called the control poly for 2N, which means 2 nodes, as opposed to 3L. So in this folder, I'm going to change this to the 3L to 2N. I'm going to reset the counter to 0. And this is now my library object. Let's do a very quick sorting right here. I'm going to place the 2N right below the 3L, and I'm going to take this node sketch, and I want it at the top, but I don't want it to get dropped in this folder. So I'm going to put it in between real quick, and then I'll drag the folder down. That reduces the chances of accidentally putting something inside a folder instead of in between them. Okay, I'm going to hide everything. Now I'm going to make a copy of this no. So this will be available later when we're building a model from scratch. We will want to take this with everything that's included. But right now what we want to do is we want to replace this curve. But we already have the segments and the points and everything. So how do I do that? If I don't want to carry all this extra stuff as new stuff, I just copy the things I need. Control copy and paste. Because I'm not starting from scratch, I don't want to create all these new objects. I already have all this extra stuff. I just want to move these things to these corners and replace the polygon in this curve so that it now follows my new 3D curve. And I will also need to do it in the main surfaces. So let's set ourselves up for success here. We don't want to be looking at the final surfaces. We want to be looking at the primary curves and surfaces. We also don't care about points. We already have them. We already have all the points we're going to need. They already belong to this curve. I'm going to take this, put it here, And once I've got it in place, I will say, this curve is now looking at my new control polygon, and I need to update these two surfaces that touch the curve, but actually updating those will be done through the grids, specifically these guys right here. I will want to update this grid and this grid. Which ones are they? It's this one, it's the last one, and this one here. So I'm going to turn them all off and only show the two that I care about. Okay, but first actually, let's get this thing moved to its proper position. When we move these node sketches here, we're not going to attach them to the curve. We're going to attach them to the layout. I always choose the shortest data path possible. So temporarily, I'm going to hide the curve so that when I pick the things to attach this to, I'm going to get the points on the sketch of the layout, not the points on the curve. Okay. So far, when we've attached things, we've used the FreeCAD attachment system. This was for two reasons. One, experienced FreeCAD users already know the attachment system, so they were able to just use knowledge they already had. People who didn't know about the FreeCAD attachment system should learn about it because it's extremely powerful and you can use this everywhere in FreeCAD. But right now I need to introduce something new that does a couple very specific tricks that the FreeCAD map mode and attachment system doesn't do easily. I want to do a couple of things. One is I want to be able to create coordinate systems to attach things to, where I say this is the origin, this is the X, this is the Y. The closest thing in map mode is plane by 3 points, and it works, but it doesn't put the origin on the first point you clicked, or at least it didn't in the past, and I found that it was a hurdle for me. The other thing is that you can, when you do a map mode by object, like we did when we attached our 3L sketches to this layout, that was fine. But when you do that, it's not easy to switch relative planes. Like, oh, you're in XY, now you want to go to XZ. When it does that, you can't combine a translation and a rotation. So I have a tool to combine a rotation and a translation. Let's see how that works. Right here, I click this point. It's a point on the layout. You can see that it highlighted the layout. Okay, I'm going to hit this tool right here, Select Pose. It created this 20 object. It comes with a standard size of 20. Let's make it 200 so we really see what's going on. This object is called Select Pose PR. P stands for position and R stands for rotation. There's a position reference and a rotation reference. Right now they're the same because we only clicked a single object. So it said, oh, the point you clicked is the position reference, and the object it came from is the rotation reference. And it said, well, right off the bat, by default, I'm going to translate the origin to the point you selected, and I'm going to use the relative axes XY of the object you selected. So I'm in the XY of this layout, but the origin has been shifted to the point I clicked. This is very neat. And right off the bat, I can say, well, now I want to be in the YZ of this object. Look at that. Now it gives me a plane in the YZ of this object, and that's actually what I'm going to use. I'm going to set myself in this plane to draw this curve. But it also does more tricks. The reference for the rotation could be from another object. I'll show you what that means and what that does later. Right now, this is what I want, so I'm just going to keep it. So I'm going to move the first node to here and the second node to this one. How do I do that? I click this point, make sure that I have the right object selected, right? That's why I hit everything else. Hit the tool again, make it 200. It's really oversized, but I want you to see it clearly. And I'm also going to put it in the YZ. So when I'm going to map these two sketches to these two objects. And when I edit the sketches, it will automatically put me in this alignment for one of the nodes and this alignment for one of the nodes. And the cool thing is it will look the same. I will have two sketches that are in different planes that control a 3D curve, but when I edit their sketches, it will put me in a standard orientation. And that's what I want for this object. So let's do it. This first one, I'm going to map. See, I still use map, but when I use map, I don't use any of the options, and I never try to do anything complicated in map mode. I won't be using these attachment offsets and stuff like that anymore when I use this system. You cannot click on the circle right here, because that will trigger weird options right here. Useful options, but not what I want. I'm going to click it right here in the tree. And you see, boom, it's snapped right here. For this node sketch, the X is now the long line and the Y is a short line. Okay. And the control polygon updated. Let's do the next node sketch. I'm going to snap it to the second salt pose. Okay. What does that do when I edit these sketches? I'm like, when I edit the first one, I'm in this plane. I'm in the local YZ plane of my cap layout. And this is really useful because when I'm working on this cap, most likely I want to be in the reference frame of this layout. That makes sense. And I can, from sketch, I can immediately switch to the next sketch, and I'm in the same plane. See, right now I have clipping on. I'm going to turn clipping off, and once again I can see the whole curve. I'm going to switch this positive 100 to minus 100. I'm going to switch this 20 to 200. Okay, so let's say that's what I want for this side. Double click this sketch. I'm right back in. It's almost like being in the same sketch. You see what I mean? Two sketches are right here. If I want to switch from one side to the other, just double click it. The view is the same, but they are separate sketches. I'm going to do 100 here. Okay, and then longer here. 200. Okay, let's say this is what I want. That's it. I have now created a control polygon for a 3D curve. How is it 3D if they're in such similar planes? It's an advantage that they look like they're in similar planes. That means that when I edit these two, I have a clear two-dimensional picture of what this curve is going to look like, but it's actually in 3D. These are not in the same plane, and so it is real 3D. We will also later do some really wild ones where none of the planes are similar to each other. It will be harder to understand. Every time we can, we want to pretend we're in a plane. We will get all the advantages of working in a plane and still actually get 3D curves. Okay. Now I want to put this control polygon and make it control my curves, and I want it to control the grids of these surfaces so that the surfaces update. So we need to think about this for a second. These surfaces are not controlled directly from the sketch itself. They're controlled from the polygon of the sketch through the grids of the surfaces. So there's three things we need to update. In this curve, we will replace control poly for 3L030 with the new one. And we need to remember this 30, because this 30 is what we will change in these two grids. If you remember earlier, I had identified, which grids is it that I'm going to update? They're in my primary setup. It's going to be this one and this one. In this grid, which one will I update? I will update 30. In this grid, which one will I update? I will update 30. Because I don't want to delete the old polygon. I'm going to leave it there in case I want to switch back to it. Okay, so we have 3 objects to update, and in each object, we're going to replace the polygon 30 with this new one. Ready? Curve. Control poly 30. Nope. I want this one. Okay. And let's let it update. A bunch of stuff broke because I haven't updated the grids yet, but the curve updated. Then I go to this grid. What do I want to update? I want to update control poly 30. That's the one I'm abandoning. Right now, I still see control poly 30 clearly, but when I update it in this grid and hit F5, F5, I don't know what I hit. Okay, this grid has jumped to the curve. Now I have the grid on top of the polygon. So when I update this grid, and I want to replace 30, now I have to be very leery of clicking in the window because I could end up selecting the grid and making a bad reference. So I'm just going to scroll all the way to the bottom. To do this last one, I'm going to click it right here. Okay, hit F5. Okay, now I see that both my grids are now reaching to the new control polygon, and the curve is going to the new control polygon. Let's get a good view of what we did at this level. I'm going to turn off the control grids. I'm going to turn off my layouts. Now this is just to show you, I'm going really slow and this is making the video longer, but I want you to see these things. My primary surface up on top is now going to the new curve, which is fully three-dimensional. This primary surface on the side is now using this curve as one of its, to define its surface, and the curve itself on the corner also goes to this surface. I'm going to leave the curves on and turn off the surfaces. Close all of this, and now I'm ready to look at my final surfaces. After the surgery is done, and we have replaced this polygon in all three objects that were affected, the main surface, the curve itself on the edge, and the surface on the other side, now I can work with my final surfaces again. Okay, remember, I still have, actually I'm going to turn auto update back off here so that it will, because I'm working with the high quality final surfaces, and now this will affect the entire model. And so this means slow update, so I don't want to be stuck every time I drag a surface around. Okay? And you can see how my final surfaces correspond to these curves, and they got blended. Notice that this corner has some really serious problems. It already had problems before. And this is a very silly edit I did here, by the way. This is a very silly edit and a highly distorted surface. And the way to fix it is not to fix this sketch. The way to fix it is to stop having the layout have this silly rotation here. If I go back to my layouts, you remember that I put in this 45-degree or whatever crazy angle up here. This is not a good design. We're going to be fighting this forever. I'm going to undo this change, and from now on, I'm going to try to work at producing objects that are beautiful, or at least sensible, as opposed to crazy, distorted objects. We will distort objects on a regular basis to stress test them, but I'm tired of looking at ugly stuff all the time. Because the point is to make beautiful objects. But I don't want to cheat you and make you think that the system is better than it is, so I show you the flaws on purpose. But you see, as soon as I made this layout not have a crazy rotation, most of the problems went away. And we can have a little bit of rotation. Let's do something sensible, like 20 degrees. This is not crazy. See, if I do 20 degrees on top, this blend is not busted, and now I can do what I call 3D sculpting, which means that I'm manipulating 3D curves to change this shape. Let's make this a little bit nicer here. So I'm working in the coordinate system of this cap. I'm going to make this a little bit smoother left to right. So here I'm going to make it 150. And now I'm not going to turn auto update. So I'm going to do both nodes and then I'll update once. Switch to the next node. Switching to nodes does trigger an update. Here, I'm going to go back down, 150. I'm going to make them pretty similar to each other. And then here, minus 200. Okay, so when this poly updates, it will go from here to here to here. Let's do it. Okay, we're going to do a lot of this. And you can see the blends work. Let me turn off a bunch of stuff here. It was useful to look at these curves. Now that we know it works, we've done the surgery on the primary surfaces and curves. We don't need to look at it anymore. Close my utilities, open the patch, hide this, close its folder, hide the layouts, I don't care. Now we have a lot of power in these things. But you remember, these two are still parallel to each other. So if I look at this thing, right now this thing is mapped to the layout. And I said, oh, I'm not going to be doing relative attachments. I could if I wanted to. It's not my favorite way of working. I've just showed you how to place these things such that there is a sensible plane to edit them from, even though they are offset from each other in 3D. That's the way I like to work. But you can just see it has a computed placement. So it's these objects here. The Silk pose will not let you add attachment offsets. But remember that the sketches themselves are still mapped to the Silk poses through attachments. So if you don't like my system, or if you only want to use my system up to this point, you could just then go here, and in the attachment offset, I can add rotations. What would be an interesting rotation for this one? Well, this is the local x-axis. This is the local y-axis. So why don't we rotate this sketch about the y? I go to axis. I set 1 for the y. Fortunately, this triggers recomputes. 0 for the z. And now I'm going to add an angle here. What's going to happen? In this attachment, which is the red object right here. Right now, this node sketch is in the XY. X and Y. And now I'm going to, in addition to that, I'm going to rotate this node sketch relative to the Y. So it's going to rotate out like this. This line here is going to sweep a cone and come out to here. Ready? Let's do 30 degrees. Oh, see, it wants to go that way. I'm going to do minus 30 degrees. And by the way, this will remain predictable. This angle is not going to flip around on you. See? I have dragged this out. And now we're more and more 3D. More 3D, please. Sir, may I have more 3D? Yes. But now, when I edit these sketches, there is no real plane to understand them from, and that's fine. And these blends, even though they're not very high quality, remember, there's more advanced things we can do. Oh, here, I can see, this is a typical defect when your primary surfaces are not completely crazy for the sake of creating defects, right? So this is fine in the early phases of the design. If you trust me, that we'll be able to fix it. There will be conditions when we fix it. There's always conditions. But this is not a bad way to work for quite a while. You can do a lot of the bulk design of your model, and once you've done the bulk design, decide which defects are the worst, and of the defects that are really bad, define how important they are to your model, and then we can talk about how to improve this model, starting from the worst defects, the most important defects, to the least important defects. But here we go. This is a 3D sculpting system where most of the time you should still try to work in a plane, as long as it's possible to do so. And you can have your planes be offset to each other and have really simple way to navigate across them. But if you want full 3D, you can either use FreeCAD attachments, but now you have a way to do it where things are deterministic. This will always be 60 degrees in the same direction. This will never flip. If you want to go the other way, you go from negative to positive because it is directly tied to the axis we've defined right here. And this object, the silk pose, is ultra stable. It will never flip on you. The downside is you're going to have to learn to use cross products to understand why I chose ZX instead of XZ. XZ appears to be more sensible at first glance, but this follows the cross product cycling of the axes. More about that later. I hope you enjoy, and I'll catch you next time.